All right, continuing on with this material here. Just kind of be honest here. Yeah, I kind of find this a little bit boring as far as the material that I am currently reading through, but something that predates me is patience, learning the ins and outs, the history, um, pretty much every possible angle there is to this can pay off in the long run. So even though this might be boring, it might be whatever, uh, doesn't mean it's not going to be useful. So with that said, let's get started on this and get through it. It's the fastest way to pretty much learn all this stuff is just to keep reading, doing it and exercising it and over and like a broken record. Anyways, if this is the first video you've seen, on the right I got Learn CPP, which is C++, a website I found it's there for a lot more information on learning C++. On the left side we have VS Code, which is what I use to practice, exercise, experiment, learn C++. Last video we left off, we were going through about 7 different steps here. When it comes to writing a program, first define the problem you want to solve. Second, design a solution for it. Write a program. Then third, write a program to implement the solution. Fourth, compile the program. Fifth, link object files or other files you have, basically putting together all the parts to it. Each one of these different steps has its own difficulties to it. And altogether, it's not that simple, but when you get it completed and get it right, it will turn out to be something great, depending on how much time and effort you actually put into every possible aspect of it. So, currently I am pretty much just reading the material. You can follow along with me or you can read it on your own either way. I do invite people if they want to do kind of study groups where you can leave comments, questions, whatnot, in the comments what you think about the material. If you're learning C++ as well. Uh, Otherwise, yeah, you can just go through it on your own or whatnot. But this is my journey on learning C++, and I'm just sharing it. So maybe this is helpful, maybe it's not. I don't know, but it's out there. So continuing our discussion of this diagnosis from the previous lesson 0.4, went through steps 1 through 3, and now we're going to continue on with step 4. Compiling your source code. In order to compile C++ source code files, we use a C++ compiler. The C++ compiler sequentially goes through each source code .cpp file in order in your program and does two important tasks. First, the compiler checks C++ code to make sure it follows the rules of C++ language. If it doesn't, normally you get an error or a warning or a message indicating that something is wrong. If it does not, the compiler gives us just what I said, um, to help pinpoint what the problem is. It might point out the line, or it might point out the code and what it was expecting, or so forth and so on. Just depends on the text editor you're currently using and the compiler you're currently using, as well as probably even the software you're currently using. The compilation process will also be aborted until the error is fixed, so will not actually run the program. Even if it does run the program and it doesn't find any errors, there could also still be a problem with the code if you don't get the expected outcome you were looking for. And there's not a lot of ways to determine if the outcome is the actual correct one or not, depending on what kind of program you're trying to write. So, second, the compiler translates the C++ code into machine language instructions. These instructions are stored in an intermediate file called the object file. I believe that's also known as the .exe file, execution file. The object file also contains other data that is required or useful in sequence steps, including data from needed by the linker in step 5 and for debugging in step 7. Now, I don't recall, I do know that W3 Schools talked about compilers. He didn't get into a whole lot of detail with the compiler, but I don't recall it ever actually discussing anything about a linker or even other files, which is what a linker is. It combines multiple files into one, uh, so it can use all aspects of everything in the program. Moving on here, we got objects files are typically named name.o or name.object, where name is the same name as a C++ file it was produced from. For example, if your program had 3.ppf files compiled, compiler would generate 3 object files. Source file calculate CPP, source file fraction CPP, source file math CPP. Those 3 would end up turning into an object file of the same name, but .o or something else. C++ compilers are available for many different operating systems. We will discuss in installing a compiler shortly. So yes, the material does go through discussing how to install compilers and which compiler would work best for you. I don't know how detailed that is. I don't know how up to date that is compared to the compilers that are currently out there, but it will go over them a little bit, so that might help. Step 5, linking object files and libraries and creating the desired output file. After the compiler has successfully finished, another program called the linker kicks in. The linker's job is to combine all the object files and the linker's job is to combine all object files and produce the desired output file, such as an executable file that you can run. The process is called linking. If any step in the linking process fails, the linker will generate an error message describing the issue and then abort. So not only can you end up having problems or errors or warnings in your source code, but then you can also end up having linker problems, which is what links files together. Most of us, when we write programs and stuff, especially if it's a long program or a big program, which most are, they're not really short most of the time. A program like this text editor and stuff probably doesn't have a whole lot to it, but it does. Something like this notepad right here and stuff probably doesn't have multiple files to it. Probably only has one file to it because of it being so simple. Moving on, first, the linker reads each of the object files generated by the compiler and makes sure they are valid. Second, the linker ensures all cross file dependencies are resolved properly. Give me just 1 second. All right, had an interruption, had to pause the recording there for a minute, so let me repeat what I just said here, just because of the interruption. I love the fact that I can pause my recordings like that, though. Okay, so second, the linker ensures all cross-file dependencies are resolved properly. For example, if you define something in one .cpp file and then use it in a different CPP file, the linker connects the two together. If the linker is unable to connect a reference to something with its definition, you'll get a linker error and the linking process will be aborted. We haven't really discussed any of that, so that's something new that I am discovering for the first time. Well, not for the first time. I've discovered it before, but you may not know about it, especially if you've been learning C++ or are following on these videos that I'm making. It's not something we've discussed yet. It's not something that W3 Schools goes over at all. In fact, W3 Schools doesn't go over anything to do with multiple files for a program you're trying to build. It just goes over one file. It goes over the idea that your program can create another file, read from that file, and make edits to that file. But it does not go over anything about creating multiple files for the same program, in which case is quite common. you can end up having 15 different files for a single program. But that's beside the point. We'll get to that later. Third, the linker typically links in one or more library files, which is a collection of precompiled code that have been packaged up for reuse in other programs. And we've seen that in the last video when I showed you how the libraries contain multiple files. You may not understand what the libraries are or what's in them, but knowing that they are comprised of multiple files, enough to contain 170 some odd kilobytes worth of data into your program. This is typically why you might consider the idea of creating your own libraries. But yeah. So finally, the linker outputs the desired output file. Typically, this will be executed, be an executable file that can be launched, but it could be a library file if that's how you set it up to be. So we got a little diagram here. So we got the object files, which the objects files were created off the main files. And then you got a linker in the center of all this. You got your libraries, other libraries, and executable file, calculated, whatnot. So there's a lot of steps that go into creating a program and getting it to work. It's not just creating a program and then running it like expecting it to work like a simple calculator or notepad or whatever it may be and stuff. There could be several files attached to any one specific program you run. And if you're running multiple programs at the same time, it's very likely you could end up with a dozen, 2 dozen, even more than that files in the background running all at the same time. So if you pull up your task manager, for example, like this right here, and you see all this right here running, most likely either some of these programs may be startup programs, some of these programs may be programs that are needed for other programs to work, but there's a ton of programs here that are required. All these contain either files or multiple files for these to run. If you want to increase performance and stuff, then you reduce down as much of the file usage as possible. Otherwise, you end up with an overclocking CPU or an overfilled memory, etc. Anyways, the standard library. Let's move on to that one. C++ comes with an extension library called the C++ standard library. Standard because it's normally the basis of what you might need to uh, develop a program. We've discussed a few of them, but not all of them. There are quite a few of them. We've even discussed many of these standard libraries that are similar to one another. Uh, but yeah, most common ones are the IOStream, I think vector, functional. But yeah, there's many more that come with that. So moving on, usually called the standard library, this provides a set of useful compatibilities for use in your programs. One of the most common used parts of C++ standard library is the input and output library, often called IOStreams, which contains functionality for printing text to a monitor and getting keyboard input from a user. Almost every C++ program written utilizes a standard library in some way or another. So it's extremely common to have the C++ standard library linked to your programs. Most C++ linkers are configured to link the standard library by default. So this generally isn't something you need to worry about. Now, one thing I will mention about that is if you are operating on a system that does not require C++, then this will not be pertain to anything you're doing at all. I don't know if Mac and Linux work the same way. I'm pretty sure that Microsoft runs with C++, but I don't know about Linux or the other ones. They may not. I do know that there are other types of programming languages that can be used for things. But yeah, so just keep that in mind that even though we mentioned that, it doesn't mean that all programs or all code languages work the same way. But moving on, third-party libraries. You can optionally link third-party libraries. So yes, you can link the standard library, third-party libraries, or build your own library, which are three different types of libraries, which are libraries that are created and distributed by independent entities. Um, and we'll get to that later and stuff as far as what other libraries you might want to include on your C++ programs based on what you're doing. Rather than as part of the C++ standard for each. For example, let's say you want to write a program that plays sound. The C++ standard library contains no such functionality. While you could write your own code to read in the sound files from a disk, check to ensure they were valid, or figure out how to route the sound data to the operating system or hardware to play through a speaker. That would be a lot of work. Instead, you'd be more likely to find some existing software project that has a library that already implements all of these things for you. We'll talk about how linking libraries, how to link libraries later on. But yeah, you could write your own program to do that. You could write your own program to do the studios for videos, editing. I mean, yeah, the list is endless. Okay, so building. Because there are multiple steps involved, the term building is often used to refer to the full process of converting source code files into an executable that can be run. A specific executable uh, produced as the result of building something called a build. I've heard of that referred to before, build. It's not something I've used a lot of, and it's something that I've still got to work on to get used to how it's done because I've only done it a couple times. And it's not something that VS Code actually has built into it. It's something you actually have to type a command for, I believe, but I'm not positive. There may be other ways around it, but I don't, like I said, I haven't studied it enough to know yet. So, for advanced readers, for complex projects, build automation tools such as Make or Build2 are often used to help automate the process of building programs and running automated tests. While such tools are powerful and flexible because they are not part of the C++ core language, nor do they need to use them to process. We'll discuss them in later. Step 6 and 7, testing and debugging. This is the fun part. You are now able to run your executable and see what it does. Once you run your program, then you can test it. Testing is the process of assessing whether your software is working as expected. Basic tests typically involve trying different inputs combinations to ensure the software behaves correctly in different cases. Um, a lot of times nowadays, this is known as actually a beta test. They will do this on their own several different ways, several different times, but then they will also release a beta program uh, just to see if any user can do anything that would cause the program to crash or have issues, so they can go through and fix it before it's actually released. Normally, there's only a few amount of people that they allow to do this because they don't want a lot of bad references or experiences with their beta project, but they also don't want problems and stuff before they actually release it fully. Let's see here. If the program does not behave as expected, then you will have to do some debugging. And these debugging processes and stuff may not be obvious. I can tell you that much right now. Because you may have written the code properly and stuff, but you may uh, not have something sit in the right place or a function working the way you want it to actually work. Okay, keep moving on through here, which is the process of finding and fixing programming errors. We will discuss how to test and do more of this later on. Integrated Development Environment, IDEs. Note that step 3, 4, and 5, 3, 4, 5, and 7 all involve software programs that must be installed. Um, Editor, compiler, linker, debugger. While you can use separate programs for each of these activities, a software package known as an integrated development environment, like the one I have here on the left side of the screen, bundles and integrates all of these features together. We'll discuss this later on. So yes, when I first got started into this, I started learning about linkers, and I was like, okay, is this another program I'm going to have to download? I did some research and I come to find out and stuff. No. When you download the compiler, a linker comes with it. Sometimes the extensions will come with linkers, debuggers, sort of things. But in my case and stuff, when I downloaded the compiler, everything I needed, the linker and the debugger, all came with the compiler. It did not come with, or the text editor, VS Code, did not come with that stuff installed. That's something I had to install afterwards. So, installing an integrated development environment. This is probably going to be a long section right here. It looks like it is because there's a lot that goes into this, especially since I think they go over more than just one. So we will save this for a new video. Kind of give you an insight on this and stuff. I think they discuss one or two different, maybe no, 2 or 3 different IDEs, how to install them, and possibly even how to install them on different operating systems. It doesn't matter if you're using Windows, Linux, or Mac. So it kind of gives you an idea if the IDE you're wanting to install or you already have installed does not, or basically what this goes over is not something you have something completely different than this, then you may have to do some more research to determine what you need to install to start writing C++. But yeah, I did not actually go through this section the first time I went to this source. So a lot of this stuff, yeah, I am kind of learning for the first time, but also I already kind of knew about a lot of it. That's why I was opting to skip this entire section again. But this time I decided, you know what, let's go and look through it, see if there's anything here that I can learn. And there is a couple things. I mean, um, not realizing just how many files and stuff may be used to run a specific program like your operating system. I bet there's thousands of files with thousands of lines of code in each file just to get your operating system up and running. It doesn't matter if you have Mac, Linux, or Windows. That may not be true for all 3 of them, but yeah, especially since all 3 of them may not even use C++. But anyways, again, if you like the video, go ahead and click the like button. If you want to have any questions, comments, anything I've said that you don't agree with, or you do agree with, or whatever and stuff, like I said, the comments are there for that, so just go ahead and leave comments. I may try to make another video today on this section right here, or I may just wait until tomorrow to do that. I am still trying to maintain somewhere between 4 to 6, if not 10 videos a day about all this stuff. So, and that's because I am trying to learn it. The more I sit here and read through this and study this stuff, the more I learn. Um, so that's mostly for my benefit than anything else. But but that's it for now. I will catch you in the next video. Thank you.